On the night of August 15, 1977, a radio telescope in an Ohio field recorded 72 seconds of noise from the direction of the constellation Sagittarius. It was 30 times louder than the background hum of deep space. It arrived on the one frequency that astronomers had agreed, for 16 years, an alien civilization would most likely use to say hello. And when a volunteer scientist read the printout a few days later, he circled 6 characters in red pen and wrote one word beside them: wow. That signal has never been heard again. Not by that telescope, not by any telescope, in 49 years of looking. It remains the strongest candidate signal in the entire history of the search for extraterrestrial intelligence, and, depending on who you ask, either the most tantalizing 30-second-hand piece of evidence that we are not alone, or a very ordinary piece of sky that we happen to misread. Tonight, what the signal actually was, character by character. Why its exact frequency is the part that makes scientists uncomfortable. Every explanation that has been proposed and knocked down, including the Comet theory that made headlines and then collapsed. And the 2024 study that may finally have found something in the same patch of sky that could produce exactly this, and never repeat. The telescope was called Big Ear, and it did not look like a telescope. It was a flat metal field the size of 3 football pitches, lying in a meadow beside a golf course in Delaware, Ohio, 2 enormous reflectors, one flat and tilting, one curved and fixed, and between them an aluminium ground plane. It had no moving dish. It could not be pointed. It simply lay there and let the rotation of the Earth sweep the sky across it, strip by strip, night after night. Big Ear belonged to Ohio State University, and it had already done serious work, mapping thousands of radio sources across the northern sky. But in 1973 it was assigned to something that most professional astronomers of the era regarded as, at best, an eccentric hobby. It began the longest-running search for extraterrestrial intelligence in history, and it ran that search on a budget of almost nothing, staffed largely by volunteers. One of those volunteers was Jerry Eman, an astronomer who had lost his paid position in a funding cut and kept working on the project without salary. Every few days he would collect a stack of computer printouts from the observatory, take them home, and read them by hand at his kitchen table. The computer could not judge what was interesting. A person had to look at the numbers and decide. Big Ear was the work of a man named John Krause, an antenna engineer of genuine brilliance who had helped design radar countermeasures during the Second World War. He built the telescope largely out of ingenuity and cheap materials. Students and volunteers laid the ground plane by hand, and when university funding dried up, he kept it running on donations. For decades it was one of the most productive radio instruments in the world, operated on roughly the budget of a small suburban school. And the search it was assigned to had a specific intellectual history. In 1959, 2 Cornell physicists published a short paper in Nature proposing that interstellar communication by radio was not only possible but likely, and that there was one obvious frequency to try. A year later, a young astronomer named Frank Drake pointed a telescope in West Virginia at 2 nearby stars and listened. He heard nothing. But Project Ozma had started something, and by the 1970s a handful of observatories around the world were quietly listening. What made Big Ear different was persistence. Most searches got a few dozen hours of telescope time. Big Ear ran its SETI survey continuously, night after night, for over 20 years, the longest continuous search of its kind ever conducted. It scanned the same strips of sky again and again, building a record of what the radio sky normally sounds like. That is why the night of August 15 mattered so much. After 4 years of listening, the machine had a very good idea of what normal looked like. To understand what he found, you need to know how Big Ear wrote things down. The telescope listened on 50 separate narrow channels at once, and every 12 seconds it printed 1 character for each channel, a compact code for how loud that channel was compared to the normal background of space. A blank space or a 1 meant ordinary noise. Higher numbers meant a stronger signal. But the scale only ran from 1 to 9. So when a signal was more than 10 times the background, the printout switched to letters. A meant 10 times. B meant 11. And it kept going up through the alphabet, each letter one step louder than the last. In 6 years of operation, the strongest thing Big Ear had ever printed in that column was a single letter well down the alphabet. The scale ran that high because nobody expected to need it. There is one more property of the recording that matters enormously, and it is easy to miss. The signal was extraordinarily narrow in frequency, confined to a slice less than 10 kHz wide. That is roughly the bandwidth of a single AM radio station, arriving from interstellar space. Nature almost never does this. Stars, gas clouds, pulsars, galaxies, they all smear their energy across broad ranges of the spectrum, because they are hot, chaotic and enormous. On the printout for the night of August the 15th, in Channel 2, Jerry Emmon found this sequence, 6, E, Q, U, J, 5. Read it as loudness, 12 seconds per character, and it describes a perfect curve. The signal rises out of the noise. It climbs, 10 times background, then 18, then 26. It peaks at you, 30 times the background hum of the universe. Then it falls away just as smoothly, and is gone. Total duration, 72 seconds. And that rise and fall shape is the first thing that made him reach for a red pen. It is exactly, precisely, the shape a fixed telescope should record when a single point in the sky, holding steady, drifts through its field of view as the Earth turns. Big Ear's beam took about 72 seconds to sweep past any given point. The signal appeared for 72 seconds. It behaved, in other words, like something out there rather than something in here. Emmon circled the 6 characters, wrote "wow" in the margin, and, this is the part people forget, did not for a moment conclude that he had found aliens. He spent the following weeks trying to prove he had found an aeroplane, a satellite, a stray transmitter, a reflection off a piece of orbiting junk. That is what the rest of this story is, 50 years of very careful people trying, and failing, to make this signal ordinary. Concentrating energy into a narrow band is, as far as we know, what technology does and what nature does not. It is the entire basis of how we search. We do not look for alien speech, we look for a tone, an artificially thin line in a naturally broad spectrum. By that standard, the wow signal is textbook. If you asked an astronomer in 1977 to describe what a genuine interstellar transmission would look like on a printout, they would have described something very close to 6EQUJ5. It is worth pausing on what Emmon actually did next, because it is the opposite of what the internet version of this story suggests. He did not call a press conference. He went looking for a mistake. He checked whether the signal could have come from the ground by examining whether it moved with the sky or with the Earth. He worked through the list of objects in the solar system that were in that direction. He requested checks on satellite catalogs. Over the following weeks he systematically tried to kill his own discovery, and could not. The name came later, and it came from the paperwork. The signal never got a formal designation. What it had was a note in a margin. Colleagues began referring to it as the wow signal simply because that was the word on the page, and it stuck, one of the very few scientific phenomena in history named after an involuntary reaction. Emmon later said, with some regret, that if he had known the word would outlive him he might have written something more dignified. Now the detail that gives this case its weight, and it is not the loudness. It is the frequency. The signal arrived at almost exactly 1420 MHz. That number is not arbitrary. It is the frequency at which neutral hydrogen, the most common substance in the universe, naturally radiates. Every radio astronomer in every country studies that frequency, because it is how you map the galaxy. And in 1959, two physicists published a paper arguing that this is precisely why a civilization trying to be found would broadcast there. It is a landmark any technological species would know. It sits in a quiet part of the radio spectrum. It is, as the paper put it, a natural meeting place, a universal frequency for a first hello. That idea became the founding assumption of the entire SETI project. For international radio law, that band is also protected, transmitting there is restricted precisely so astronomers can listen in peace. So a very loud, very narrow signal, holding perfectly steady, arriving on the one frequency that is both universally significant and legally kept quiet, that is why an unpaid volunteer with a red pen took it seriously, and why professional astronomers have never quite been able to put it down. And there is an arithmetic to it that is worth sitting with. If the signal came from a star 200 light-years away, a reasonable distance for that patch of sky, then the transmitter that produced it would have needed a power output in the range of billions of watts, focused into a beam. That is far beyond any single transmitter on Earth, but it is not physically absurd. It is roughly what you would get from a large planetary radar dish, of the kind humanity has already built, if it happened to be aimed at us. Where did it come from? Because of how Big Ear was built, with two separate feed horns staring at slightly different parts of the sky, the answer is frustratingly double. The signal appeared in one horn but not the other, which narrows the source to one of two narrow strips of sky. Both lie in the constellation Sagittarius, in the direction of the galactic center, a few degrees from a star cluster called Messier 55. It is a crowded, ordinary-looking patch. There is no obvious star, no known planet, nothing marked on any chart that says look here. Later surveys found a handful of sun-like stars in the region, tens to hundreds of light-years away, but nothing that stands out. Whatever transmitted for 72 seconds in 1977 left no address, and pointed at nothing we can name. There is also the timing problem, and it is nobody's fault but it hurts. The signal was recorded automatically onto paper in an empty building. Nobody was watching the readout that night, and nobody looked at the paper for several days. By the time Emin circled those 6 characters, the sky had turned, the moment was gone, and the chance to swing another instrument onto that patch while it was still transmitting had passed. The single most important observation in SETI history was made by a printer, alone, in the dark. The two-horn problem deserves a moment, because it is the strangest small detail in the file. Big Ear had 2 receivers looking at slightly different patches, separated by a few minutes of sky. Any real source drifting past should have appeared in one, then the other, a couple of minutes apart. The wow signal appeared in only one. Either it switched off in the interval, or it was aimed in a way that caught one horn and not the other, or the source moved. Every option is uncomfortable, and which horn saw it has never been definitively established. And there is the distance to think about, which changes the emotional weight of the whole thing. If the signal came from 200 light-years away, it left its source around the time of the American Revolution. It crossed a distance no human object will traverse in any of our lifetimes, arrived at a metal field in Ohio, and was recorded onto paper, during which time whatever sent it may have risen, fallen, and been gone for centuries. Everything we would ever learn from it would already be history. And here is the fact that has defined the case ever since: nobody has heard it again. Emin himself went back over the same strip of sky with Big Ear more than 50 times in the months that followed. Nothing. In 1987 and 1989, a much more sensitive search called Meta looked. Nothing. In 1995 and 1996, astronomers pointed the Very Large Array in New Mexico at it, an instrument capable of picking up a signal 100 times weaker. Nothing. In 1999 and 2002, an American engineer named Robert Gray tried again with dedicated instruments, including a large telescope in Tasmania and a radio observatory in Ohio. He listened for hours. He found nothing. Every serious attempt to hear the wow signal a second time has failed, and that failure is the single strongest argument against it being anything at all. Because a beacon that shouts once, for 72 seconds, in 50 years of listening, is a strange kind of beacon. Any civilization trying to be found would repeat. And a signal you cannot verify is, scientifically speaking, not a discovery at all. It is an anomaly, one measurement that no one else has ever been able to reproduce. Which is exactly why the arguments about it have never been about aliens. They have been about what else it could possibly be. In 2012, on the 35th anniversary, an attempt was made to answer. The Arecibo Observatory in Puerto Rico, then the largest single dish on Earth, beamed a transmission back toward the WOW. Coordinates, carrying around 10,000 messages crowdsourced from the public, encoded with a repeating header so any recipient could tell it was artificial. If anyone is listening at 200 light-years, the reply will arrive around the year 2212. Nobody involved expects to be alive for the answer. The man who worked hardest on it was Robert Gray, an amateur in the best sense, a data analyst by profession who spent decades and his own money chasing a repeat. He booked time on telescopes in America and Australia, wrote the definitive book on the case, and argued patiently that a signal that appears once might simply be a beacon that sweeps, a lighthouse, turning, that we have not been lucky enough to catch a second time. Gray died in 2021 without ever hearing it again. So let us go through the ordinary explanations, the way Emin did. An aircraft transmitter. Aircraft do not broadcast in that protected band, and a plane would drift across the beam at the wrong speed, producing the wrong shape. A satellite? In 1977 there were few satellites in the relevant orbits, none licensed to transmit there, and a satellite in low orbit crosses the beam far too quickly, while one in high orbit would linger far too long. 72 seconds is the fingerprint of something that is not moving with respect to the stars. A ground transmitter reflecting off space debris? Possible in principle, and taken seriously, but it would have to reflect at exactly the protected frequency, hold perfectly steady for 72 seconds, and then never do it again in half a century of monitoring. Interference from the telescope's own electronics? The signal appeared in one feed horn and not the other, which is the opposite of what internal interference does. A hoax? Every serious reviewer has dismissed it. Emin had no motive, gained nothing, and spent the rest of his career carefully arguing against overinterpreting his own discovery, which is not how hoaxers behave. And a natural astronomical source? Pulsars, quasars, and the rest all have signatures nothing like this. They are broad in frequency, and this was extraordinarily narrow. Narrowness is the point. Nature spreads energy out. Technology concentrates it. And the lighthouse idea is worth taking seriously, because it dissolves the strongest objection. We assume a beacon should repeat, but that assumes it is aimed at us and left on. A transmitter sweeping its beam across the sky, or pointed somewhere else entirely with Earth catching only the edge, would produce exactly one detection and then silence. The trouble is that this argument is unfalsifiable, it explains the silence perfectly, and it can never be tested. In science, an explanation that survives any evidence is not a strength. It is a warning sign. In 2016 and 2017, a professor at a Florida college announced that he had solved it. His proposal, 2 comets, catalogued only in the 2000s, had been passing through that exact region of sky in August 1977. Comets are surrounded by vast clouds of hydrogen gas, and hydrogen radiates at 1420 MHz. A cloud drifting through the beam, he argued, would produce a strong signal that never repeats, because the comet moves on. The story went around the world. It was, for a few months, the accepted answer. And then astronomers checked the arithmetic, and it fell apart. The comets were not in the right part of the sky at the right time. Comet hydrogen clouds are broad, not narrow, the opposite of what Big Ear recorded. And crucially, Big Ear had scanned that same region repeatedly while those comets were nearby, and detected nothing. Radio astronomers, including the observatory's own veterans, rejected it comprehensively. The comet episode is, in its way, the most useful chapter in this whole story, because of how the scientific community handled it. A claim was made. It was covered breathlessly by the world's press as a solution. Specialists then checked it against the archival data, found it failed on multiple independent grounds, and said so publicly. The headlines never caught up. A great many articles online still state flatly that the wow signal was comets. It wasn't. This is what it looks like when a mystery gets solved in public and then unsolved quietly. Which brings us to the most interesting development in decades. In 2024, a team led by Abel Mendez at the University of Puerto Rico at Arecibo was combing through archival data from the Arecibo Observatory, the giant dish in the Puerto Rican jungle that collapsed in 2020, and found something they had not expected: rare, brief, narrow brightenings of hydrogen clouds, similar in character to the WOW signal, though far weaker. Their proposed mechanism is elegant. A cloud of cold hydrogen sits quietly in space. Something extremely energetic, a flare from a magnetar, or another sudden burst, sweeps through it and briefly stimulates the hydrogen, causing it to blaze at exactly 1420 MHz for a matter of seconds, then fade. A natural maser, a cosmic laser, made of hydrogen, that flashes once and goes dark. It would explain everything the case demands: extraordinary narrowness, extraordinary brightness, an unrepeatable event, at precisely that frequency, from precisely that kind of sky. It is the best natural explanation anyone has ever produced. But be careful how you hold it, because it is a hypothesis, not a verdict. The events Arecibo found were far weaker than the WOW signal, and no one has yet caught a hydrogen cloud flaring anywhere near that brightly. The paper proposes a mechanism. It does not close the file. There is also a way to test it, which is what makes the 2024 proposal genuinely scientific rather than merely clever. If cold hydrogen clouds really do flare like this, then modern instruments, sweeping enormous volumes of sky continuously, should eventually catch one in the act. Several such events, at that brightness, would settle the WOW signal for good. Not one has yet been recorded. The hypothesis is doing what a good hypothesis should, sticking its neck out. And the search itself has changed beyond recognition. Where Big Ear listened to 50 channels and printed on paper, today's projects scan billions of channels simultaneously and process the results with machine learning. Breakthrough Listen alone has surveyed thousands of nearby stars. In half a century of vastly improving technology, there have been a handful of interesting blips, and every single one of them, on examination, has turned out to be us: a satellite, a phone, a microwave oven in an observatory kitchen. That is the context in which the WOW signal has to be judged, and it cuts both ways. On one hand, 50 years of listening, ever more sensitively, and nothing has ever come close again, which suggests strongly that whatever it was not a civilization beaming at us. On the other, in 50 years of listening, with far better instruments, nothing has ever come close again. Whatever produced those 72 seconds, it remains, by a wide margin, the strangest thing our species has ever recorded from the sky. Behind all of this sits a much older question, which the WOW signal keeps poking. The galaxy contains hundreds of billions of stars, most of them older than the Sun, a great many with planets. If technological life is at all common, the sky should be busy. It is not. It is, as far as our instruments can tell, completely silent. That silence is the real mystery of the field, and every candidate's signal is measured against it. Which is why professionals treat this case the way they do, not as evidence of contact, but as the single best documented reminder of how thin our monitoring actually is. For 72 seconds, one instrument in one state, listening to one narrow band of frequencies, in one direction, happened to be pointed at something. We were not watching then, and we are barely watching now. The sky is enormous, and our attention has always been a very small window. Big Ear did not live to see any of it. In 1998, the land it stood on was sold, and the telescope that ran the longest SETI search in history was demolished to extend the golf course next door. There is a plaque. The strongest candidate signal ever recorded in the search for other mines came from an instrument that was bulldozed for 9 more holes. Jerry Emmons spent the rest of his life being careful. He never claimed it was aliens. He pointed out, repeatedly, that a single unrepeated observation proves nothing, and that the most likely explanations were mundane ones we had not yet identified. But he also refused to pretend the thing away. Asked about it decades later, he said, in effect, we should have seen it again, and we didn't, and that is what keeps it interesting. So here is what the evidence supports. For 72 seconds in August 1977, a narrow, powerful radio signal arrived from the direction of Sagittarius, on the exact frequency that both nature and any competent civilization would pick, with the precise rise and fall shape of a fixed point in the sky. Nothing local explains it. Nothing has repeated it. And the best natural explanation we have is only a few years old, still unproven, and requires an event nobody has yet directly observed. So let us go back to it one last time, on the night itself. August the 15th, 1977. Ohio. It is a warm summer evening in a meadow beside a golf course, and there is nobody in the building. The telescope cannot be pointed and does not need to be watched, it simply lies in the grass with its face to the sky, and the Earth turns beneath it, dragging the constellations across its field of view at the speed the planet decides. At around 10 to 11 at night, local time, the beam reaches a patch of Sagittarius. And something in that direction, a cloud of gas struck by an unimaginable energy, or a machine built by somebody else, or a thing we have not thought of, is putting out a narrow tone at 1420 MHz. For 72 seconds it slides across the telescope's field of view, rises, peaks, and falls away. In an empty room, a printer types 6 characters onto a roll of paper, and keeps going. Nobody hears it. Nobody is there. The paper stacks up through the rest of the night and the following days, and the sky moves on. 3 days later a man without a salary picks up the pile, sits down at his kitchen table, and reads down a column of ordinary numbers until he reaches 6 characters that should not be there. He reaches for a red pen. That gesture, a circle and one word in the margin, is the entire physical record of the loudest thing anyone has ever heard from the sky. So, your verdict. Theory 1, a natural event, a hydrogen cloud flaring once, exactly as the 2024 work proposes. Theory 2, something local we have simply never identified, 49 years on. Or Theory 3, 72 seconds of somebody else's radio, crossing an unimaginable distance, and arriving at a metal field in Ohio on a night when one unpaid volunteer happened to be reading the paperwork. 1, 2, or 3, tell me in the comments. And subscribe before you go, because every story on this channel ends the same way, where the trail stops, and the questions start. At the last coordinate.